We'll get started here soon. Just gonna wait a little bit longer. All right, let's go ahead and get things started. All right, so last time we ended up on the 2017 chapter round target round. We wrapped up on problem number 5, so we just got a few questions left here before we move on into the next round. Let's go ahead and take a look. So as always, if you guys did a problem, or if you guys have an idea on what to do to solve a question, feel free to speak up, and then I'll we'll hear you out. Otherwise, then I'll just lead us through the problems. Okay, the first problem here, problem number 6. Did anyone get to do this one?
No.
No. Anyone else do this one here?
No.
No? Okay. Let's just lead you through it then. So from what we know a couple things. So first things first, we know that A, B, C, D, and 6 are positive integers. We know that A is bigger than B, and each of the last 3 terms is the average of the previous 2. We're looking for the value of A. So first things first, if we know that A and B, if the average of A and B is C, then we know that C has to be smaller than A, right? Because if we average 2 numbers and we know that B is lower than A, right? It's always going to be in the middle of the 2. So we know that C is bigger than B, but C is smaller than A. What we also know is that 6 must be the average of C and D, right? So there's a couple things that you can maybe try here. First off, you can try and see, hey, what happens if I say, so what's 2 numbers that average up to equal 6 pretty easily?
You, 4 and 2.
4 and 2 would average up to be 3, right?
Oh, so, yeah, right now.
7 and 5.
Yeah, you could say maybe 7 and 5, right? So like, what happens if I pick 7 and 5 here? Well, if I do 7 and 5, if I say that this number is 7 and this number is 5, then this number over here needs to be pretty big in order to make this 7 work out, right? But that wouldn't work out because then if this number is big, then this number needs to be small, right? Which would not work for my A is bigger than B. So I need to have it the other way around. I need this number to be 5, this number to be 7. What 2 numbers add up to give me an average of 5? Hey, this is going to be 3, right? And then, so like 3 and 7 average up to be 5. And then 11 and 3 would add up an average to be 7. So this works out. So 11, 3, 7, 5, 6. These are my 4. These are the 4 numbers that I don't have. You can take a look here just to kind of double check. 11 and 3 average together to equal, they add together to 14. They average together to be 7. 3 and 7 average together to equal 5. 7 and 5 average together to equal 6. So the big key here is a couple things. You can see that as these two numbers get further and further apart, these numbers over here get further and further apart. So if you pick two numbers that are too far apart here, you're going to start getting negative numbers here, which won't work out for you because you're told in the question that these are all positive integers. So that doesn't work. You're also told in the question that you have to have all of these numbers as averages together to equal the next one, right? So that's why we learned, hey, maybe we should start. That's why we started with the 6, because starting with 6 means that we actually know what this results in. So that gives us a little bit of an idea on where to go. So that's the idea here. Are there any questions over this approach that we did here? I know this approach seems kind of too easy for the question, but that's really just it here. I mean, this is the easiest way to do the problem. We just say, hey, if we work this way, you get the answer pretty quickly.
I have a question.
Mhm.
Like, how do you know if that's
This is the only answer?
Yeah.
Yeah. So I was pretty sure that's what you were going to ask, right? But we saw earlier that if you did 5, 7 in this order, this wouldn't work out, right? Because this number over here needs to be bigger, right? Bigger than 5. And then this number here needs to be smaller, which wouldn't work, right? Because we were told that A is bigger than B. So this cannot work, right?
Yeah.
Okay. Next, what you could do is, first off, the question is worded in a way such that there's only a single value of A, right? You're not told like what's the average of the values of A that could work. You're not told that. You're also told that these are all positive integers. So then the next two numbers that would sum up to and give you an average of 6 would be 8 and 4, right? So if you did 8 and 4, this number would have to be 0 to give you an average of 4, which you cannot do, right? Because you're told they have to be positive integers. So any further, it doesn't work out. But yeah, you can see that as these numbers get further and further apart, this number gets smaller. Does that make sense, Sarah?
Yeah.
So the easiest way to do this question is to take a look at it this way. Now, any closer and your numbers just become all 6s, which also doesn't work because A must be bigger than B. So this is the easiest way to do it. There's another way to do this that uses a lot of algebra, but I promise you, this is the easiest way to do it. You don't want to do it any other way. Any questions here?
Wait, so we kind of just got lucky. We just got a lucky guess.
Not quite, because you should recognize that if these numbers are further apart, this number is going to be more different.
Okay.
It's gonna be further away, right? Because if you're saying, hey, I want to find an average of two numbers, right? I want the average to result in a 3 while one of them is, a 9, right? Well, this number over here would have to be -3 plus 9. That gives you your total of 6, right? So if this number becomes bigger, this number needs to be smaller and this number needs to be smaller. That's the general idea. So that's why we pick these two numbers to be as close as possible so that this number over here is positive. So a little bit of a lucky guess, but it was an educated guess. It wasn't a pure, shot in the dark. Does that sound good?
Yeah.
Okay. And the reason why I'm not showing you the algebra method is because I think the algebra method would just be really confusing. I don't think it's worth going through. But yeah, let's go ahead and take a look at the next question then. Problem number 7. 3/5 of the way up a hill, Jack and Jill realized that they had forgotten their bucket. Jill continued up the hill while Jack went back down the hill to get the bucket. 2 minutes after turning back, Jack reached the bottom of the hill at the exact same time that Jill reached the top. If the total distance from the bottom to the top of the hill is 1,260 feet, what is the absolute difference in Jack's downhill speed and Jill's uphill speed in feet per second? Okay. Allison, I saw you had your hand raised. Was that an accident? Did you have a question or did you want to answer?
Is it 2.1 feet per second?
How'd you get it? Can you explain?
First, 1,260 times 3 to the 3 over 5 is 756 feet. And then 1,260 times 2 to the 5th is 504 feet. Those are for Jack and Jill's.
Oh, 706. Wait, did you say 706 or 760?
756.
756. Got it. Okay. All right. And then 1,260 times 2/5 was how much?
504.
All right, got it. Good. Okay. I was looking at 760 and I was like, that doesn't look right. Okay. This looks a lot better.
Okay, subtract them and then divide it by the time. Changing from 2 minutes to 1 second is 120 change. So minus that, divide it by 120, and then you get feet over sec.
So this is correct. Do you know why you did it this way? Can you explain why this is the method?
I drew a hill and divided up into fifths.
Yeah, so 3/5 of the way, this is where they were. That's a little bit more than 3/5, but okay, 3/5 of the way, this is where they were, right? So this distance here, this is the amount of distance that Jack goes, right? And then this distance up here, this is the amount that Jill goes, right?
Mm-hmm.
Okay, so then what you're saying is, all right, well, the difference between their speeds should just be the difference in the distance divided by the time, right? Is that what you said? Okay.
Think so.
And yeah, and that is the case, right? Like you can think about it this way. If one person is going, I don't know, 10 miles per hour, and another person is going 5 miles per hour, in the 1 hour time, their difference is going to be 5 miles, right? Which is, the difference between their speeds multiplied by 1 hour. So yeah, that's totally viable. Yeah, so then this right here, this does work. Now, the only thing that I would say here, Allison, is there's actually a further way to make this easier. You know how you said how you multiplied these two out and then subtracted?
Oh, wait, you should just times it by 1.
Yeah, that's the only thing that I would have said to make this easier. Just take the 1,260, multiply that by 1/5, which is the difference in the amount of the hill that they are walking up or going down, I guess. But yeah, and then that should directly get you to 252. But yeah, any questions from anyone else here? I know we went through this question really quickly. But are there any questions here from anyone else? Over the method, any of the formulas, any of the ideas that we had here, anything? No questions? All right. Let's take a look at problem number 8 then. Problem number 8. 25 chips, each marked with a different integer from 1 through 25, are placed in a jar. A student draws a chip from the jar and tells everyone the number. The chip is then returned to the jar. So there is replacement here. 9 more students do the same thing. What is the probability that at least 2 of the 10 students draw the same chip? Express your answer as a decimal to the nearest hundredth. Ooh. Okay. Did anyone get to do this one here?
Me?
No.
No? Okay. I heard 2 no's and a me. The me was from Gracie. Gracie, what did you do here to get the answer? Seems pretty difficult, right? It seems like you have to count all of the different probabilities, add them together. How did you do it?
I'm very, very sure this is wrong, but I did 1/25 times 1/25, which is 1/50.
That's 1 over 625.
Oh. If I add them, it would be 1/50.
No, if you add fractions, you only add the numerator. You don't add denominators ever.
Wow, then I'm pretty sure it's wrong.
So like 1/25 plus 1/25 is equal to 2/25, right? This is how fractions are added, right? Like think about 1/2 plus 1/2, right? This is not equal to 1/4, right? Like this is equal to 1.
Yeah, I got it wrong.
Yeah. Okay, I want to hear the logic for the rest of it. Like, so what was the logic behind it? Even if the calculation is wrong, let's see if the logic was right. What were you gonna do?
I have no clue.
You have no clue? Okay. All right. Then in that case, then looks like this one is one for me. Okay. Let me get a helper. Anna, I haven't seen you in this class very much before. Anna, do you want to help me out here?
Yeah, I'm new. Sure.
Okay. Yeah, no problem. Okay, so Anna, have you ever heard of what's called complementary counting before?
No.
Do you know what the word complement means? Complementary? Complementary is better, not just complement. Complement is actually complement with an E is good. Complement with an I is different. Do you know what complement with an E means?
I think there's like complementary angles.
Yeah, but that's actually a little bit of a different meaning. That means that they add up to 90 degrees. But if you think about them in the right way, it's the same thing. Have you ever heard of how, like for example, this dish complements something else really well, or this is a good complement to something else?
Yeah,
Do you
they
know what
like
that?
they work together.
They pair up really well. But do you know what do you know what always is said to pair up well?
No.
Like if you have something sweet, you're going to look for something salty. If you have something black, you're going to look for something white. Those are said to complement each other well. Do you know why? Think more along the
No.
black and white lines. They're opposites.
Oh.
Complement actually, in this case, tends to mean opposite. So when I say complementary counting, what this means is complementary angles is the opposite of the angle, kind of in a sense, because it's the one that you need to add to meet 90 degrees. But anyways, so complementary here means opposite. So whenever I say complementary counting, what that means is you're going to be counting the opposite of what you're looking for. So if you are looking for the number of ways that you can have at least 2 of the people draw the same chip, what does that mean? If you're counting the opposite.
8 people who do not draw the same chip.
Well, if 8 people don't draw the
Oh.
same chip, then 2 people do, right?
Yeah.
Which does fit in here. So what happens when this is not filled? When this is not fulfilled?
I don't know.
You don't know? Okay, let's think about it a different way then. What situations would this be true? So if 2 people draw the same chip and every remaining person, so all the remaining 8 draw a unique one, that is good, right? That is counted here, right?
Yes.
If 3 people draw the same one and then everyone else draws a unique one, that's counted here as well, right?
Yeah.
If 2 people drop chip 1, if 2 people draw chip 2, that's also counted here, right? Do you kind of see where I'm going with this?
Yeah.
So as long as there's any repeats, this gets counted, right?
Yes.
So what happens if there's no repeats?
Then it's not counted.
Then it's not counted. So the only situation in which this is not true if every single person gets a unique chip. Does that make sense?
Oh, yes.
So now what we're looking for is what is the probability that there is no duplicate chip drawn between all of the 10 people that are drawing a chip. Does that make sense?
Yes.
But remember, this is the opposite of what we're looking for. So at the very end, we're going to need to do something special. So first things first, let me ask you, when the first person draws a chip, which of the 25 can he draw?
1 through 25.
He can draw anything, right? There is no way for this to be a duplicate already because he's the first guy, lucky man, he's fine, right? So 25 out of 25 for the first guy is totally okay. We don't care about this guy. Sound good so far?
Yes.
Now let's think about it this way. He draws out a chip. Now it's a loaded bullet. It's one of the bullets in the 25 chambers of Russian roulette. If anyone else draws it, they're doomed, right? So for person number 2, out of the 25 chips, how many can he pick to stay alive?
24.
24. Person number 3?
23.
20, you get the point here, right?
Yeah.
So as you move on, so person number 1 has a 25 out of 25 chance to stay alive. Person number 2 has a 24 out of 25. 3 has 23 out of 25. And all the way down, right? Because each time they're picking from 25 total chips, there is replacement here. So all the way down to person number 10, what is the chance that person number 10 draws a unique chip then?
16 out of 25.
So why is it 16 and not 15?
Because the first person, you didn't subtract 1
Right.
from 25.
Right. First person did not subtract 1, so only persons 2 through 10 get subtracted by 1 each. So that's why it's 16 out of 25. So now we just multiply all of these together. And there's actually an easier way to do this. Do you know what the easiest way to represent this is? Instead of putting it as instead of doing 24 times 23 times 22 times 21, instead of typing that long line into your calculator, is there an easy way to type this? Have you heard of this before?
Factorial?
Yeah, factorial. N factorial is just equal to 1 times 2 times 3 times 4 all the way up to times n. But we don't have the numbers 1 through 15. So what do we do here?
Wait, what did you ask?
So n factorial is 1 times 2 times 3 up to n.
Yes.
And but here we only have 25 to 16. We don't have 15 to 1. We're missing these. So what do we need to do with that?
Subtract 15 factorial.
It doesn't work that way.
Oh.
You're pretty close. You have to
Or
divide by
divide.
15 factorial,
Okay.
right? Because all the numbers are being multiplied, right? So that's why if you divide them all, they cancel out that way. So this is going to be 24 factorial, because remember, this one's 25 over 25. We can ignore it. Divided by 15 factorial, then times 1 over 25 to the 9th power. This is the probability that everyone gets a unique chip. Does that look good to you?
Yes.
Are we done?
No.
Why not?
Because we did the complementary counting, so
So what do we do now? Let me ask you. let me ask you, Anna. Is there only 2 circumstances in this world? 2 situations. Situation 1, everyone gets a unique chip. Situation 2, someone gets a repeat. Are these the only 2 situations?
No.
No? There's another situation which
Oh, wait. Wait, I don't know.
so if no one gets okay, so if no one gets a repeat, then everyone gets a unique. Is that right?
Oh, yes.
So they are perfect complements to each other. If case number 1 does not happen, it has to be case number 2. If case number 2 does not happen, it has to be case number 1. Does that make sense?
Yeah.
So that means that these 2 things must add up to 100% of the case. Because if you're not in situation 1, you have to be in situation 2, which means that these 2 things encompass the entire universe. Make sense?
Yes.
Basically, it's the same idea as saying you either wake up or you don't. right? Either this happens or it doesn't, right? So that's the situation here. So in order to find the probability that this does not happen, that's just going to be 1 minus this probability. Does that make sense?
Yeah.
So our final answer is 1 minus this. This thing is basically impossible to do by hand. So you just plug this into your calculator and you get that this answer here was about 12.44%. So your final answer is 0.88. Does that make sense to you?
Yes.
Gracie, Allison, everyone else, does 0.88 here look good to all of you?
Yeah.
Yep. Okay, sounds good. Looks good. All right, so that's really just it here. This is a very good example of complementary counting, complementary probabilities. The general idea here for complementary probabilities is whenever there's a really big keyword that will always tell you to use complementary counting. If you ever see the word at least, or at most, or more than, or less than, if you ever see anything like that, that's a pretty big hint that you should look for complementary stuff. But yeah, so if you ever see at least, at most, or not, anything like that, yeah, you're probably going to look for a complementary counting. Yeah, so that's what we're looking at here. You just find the probability that everyone is unique, and then just subtract that from 1. All right, let's go ahead and move on then. Moving on to the team round. So team round from the 2017 chapter exam. Hopefully some of you guys got to take a look at some of these questions. Let's take a look here. Problem number 1. Anyone do this one?
I did.
All right, let's hear it. What answer did you get first?
31.
You got 31?
Yeah.
Ooh. Okay, how'd you do it?
Okay, so I just did I forgot what I did. Let me see. Okay, well, I just found all of the primes that are a Legato number.
I see. That's the first thing that you did wrong.
Oh.
So can you read the definition of Legato prime real quick?
A Legato prime is a Legato number greater than 1, which is not divisible by any Legato number other than 1 and itself.
So the definition of Legato prime never says it has to be a prime number.
Oh.
That's the first thing. That's where you messed up.
Oh my God.
Does that make sense?
Yeah.
Okay. So what you should have been listing out instead are what kind of numbers?
I guess numbers.
A Legato prime is a Legato number. So you should have been listing out Legato numbers instead. Make sense? Let's go ahead and list those out. So it's in the form of 3n plus 1, where n is a non-negative integer. So the first non-negative integer is going to be 0. So 3 times 0 plus 1 is 1. Keep going after this. What are my next few?
Then it's going to be 4.
Yep.
10.
Where's 7?
Oh, wait. Oh, yeah, 2. Okay, 7.
3n plus 1 is just, in this case, you're just adding 3 onto each time. So you just add 3, keep on adding 3. 10.
13. 16. 19.
Yep.
And so on.
Yep, 22, 25, so on and so forth. We may not need to go that far, but we'll see. So now what we're saying is Legato primes are numbers that are greater than 1, so 1 does not count, which are not divisible by any Legato number other than 1 itself. So 4 is good, right? Because 4 is only divisible by 1 and 4, nothing else here, so we're good.
So it's 19.
Yeah, because 7, 10, 13, and 16, the 16 is not good, right? Because 16 is divisible by 4, so then your number is 19. Yep. 7, 10, 13, 19 are all good as well. So answer here is 19 instead. Okay. Any questions here from anyone? All right. let's go ahead and move on then. Problem number 2. Haha. You guys know this one. For if you guys are in geometry, we actually just finished up this section today. A circle is inscribed in a right isosceles triangle whose legs are 8 inches long. How many square inches are the area of the shaded portion? Express your answer as decimal, rounded to the nearest hundredth. Right isosceles triangle. We've seen this one before. Anyone do this one? No one? Really? I would have expected the people in geometry to know this one.
No.
Isabella, did you do this?
I didn't get to this packet. I finished
Gotcha.
the other one. I thought that was the only homework.
Okay. All right. Let's have you work through it right now then. So, what's the first thing that you should do when you see this question?
Basically they said it's a right isosceles triangle, so the top part is a right angle, and then basically the bottom two angles are 45 and 45 because it's an isosceles.
Yep. So you know that these two angles must be 45 degrees each. This angle in the middle must be the right angle. And more specifically, what kind of triangle is this?
A 90, a 45, 45, 90.
Yeah, this is a 45, 45, 90 degree special right triangle, right? So what must this length over here be?
Is it 2x, x, and x square root 3? No, that's 30, 60, 90.
Yeah.
It's x square root 2.
Okay.
Yeah.
Yep. So what is the value here?
And then the other sides are x. So then it's 8 square root 2.
Okay. Does anyone have questions on where these values came from? Is everyone familiar with special right triangles? If anyone's Gracie, did you say something?
I said yes.
Okay. If anyone is not, then I'll go over it real quick. But I think we've covered this before in this class too. But yeah. So yeah, this right here is 8 root 2. That's what we're looking at. So these two sides are both 8s. That means that this right here needs to be 8 root 2. Okay. What else can we do then? Isabella?
So they want to know the area of a shaded portion, and I don't know how to do area of whatever shape that sort of is. So you basically, I think you just get the area of the whole triangle and then subtract it by the circle's area.
Yeah, so find the triangle area, then subtract the circle's area. Yes, I do agree with you. So how do you find the triangle area first?
It's base times height times 1/2.
Yep.
But
so
there isn't the height yet, so.
What do you mean? It's a right triangle.
Oh, right. I'm looking at the wrong way then. Yeah, so it's 32. Yeah, so it's 32. And basically you have to subtract it by the circles. And
we'll just say pi r squared for now.
Yeah, okay.
Do you know a formula for r?
Not really.
Not really?
Like, what are you kind of talking about?
The formula that we learned at the end of class, like an hour ago.
Oh, that formula. Okay. So, yeah, okay. So that one. Okay. So it's, so it's the intercircle is.
In circle.
Circle. Yeah, circle. In circle is whatever circle this one is. And then we have to find like the angle bisectors of that. So it's,
well,
and then for this one, I think it's in the middle for a right triangle.
okay. First things first, you actually don't care about where the angle bisectors are at all. You just care about the fact that this is your in circle. And you're told that this is a circle that is inscribed, so you do know it's an in circle. You know that this is a circle that is inscribed inside of a triangle. Now, the formula that you get here, the formula that I was mentioning, was that the radius of this circle times your perimeter of your triangle divided by 2 is equal to the area of the triangle. This is the formula that I was referring to. If you're looking for a proof of this, I can give one pretty quickly, but the general idea is you split this triangle into 3 different parts. The inscribed circle is a tangent to all 3 of these points. That means that it is 90 degrees to all 3 of these sides. And then if you split this up into 3 different triangles this way, so triangle number 1, triangle number 2, triangle number 3, each of these is respectively a side times the radius of the circle divided by 2. Add all these 3 together, you basically add the sides together, then divide by 2. That's the perimeter of the triangle divided by 2 times the radius is equal to the area of the whole triangle. That's the proof here. I know I went through it really quickly, but I promise you it's not very important. The proof isn't very important. What's really important here is the formula here that we want to use. So if we use this formula, we get that the perimeter of the triangle divided by 2, that's going to be 8 plus 8 plus 8 root 2. That's 8 plus 4 root 2 times the radius of my circle must be equal to 32. So now we just divide by 8 plus 4 root 2. So now we have 32 over 8 plus 4 root 2 is equal to r. And this seems really hard to divide. However, there's a surefire way to do this. This actually, the way that you can do this is you can think of this bottom part right here as 4 times 2 plus the square root of 2. So this becomes 8 over 2 plus the square root of 2 is equal to r. Well, you might ask, well, how do I take care of that then? Well, the way to take care of that is to rationalize your denominator. Now, you may not have seen how to rationalize your denominator here, but I will tell you it's very simple. You just multiply by 2 minus the square root of 2. And the reason why is because this is a plus b. The easiest way to make that a squared minus b squared is to multiply by a minus b. Because if you have b squared, then you don't have to worry about your square root of 2. So you multiply by 2 minus root 2 over 2 minus root 2. So this becomes 16 minus 8 root 2 divided by 2 squared minus 2, which is 2. So now your answer is r is equal to 8 minus 4 root 2. Any questions so far? So if your radius is 8 minus 4 root 2, then now all we have to do is we have to plug it back into this equation up here. 8 minus 4 root 2 squared is equal to 64 plus 32 minus 64 root 2. So your final answer here is 32 minus 96 minus 64 root 2 pi. And then this should get you approximately 14.75. Right. Any questions here?
About how we got 32, is it just 8 plus 4 root 2?
No. This 32 right here, right? Which one? This 32 or this 32?
The 32 from before.
This was just 8 times 8 divided by 2.
Oh.
Yeah, because these two meet at a right angle. So that's your base and your height. Sarah, do you have questions here? I'm sure you have a decent amount. You haven't seen any of these formulas before, right?
I think we've done a few of these the circle inside the triangle things in previous classes. So
Yes, we have, but I don't think I ever explained the formula until now.
yeah.
Does
I
the
think
formula make sense? Okay.
Maybe can you explain the formula part again?
Yeah. I'll do that real quick. And this last part is all just a lot of multiplication by radicals and stuff like that. Okay, so if we have this point in the center, this point to all three of your sides is going to be perpendicular. And the reason why is because it's a circle that only goes through this side a single time. So it needs to be perpendicular to that point. It's called a tangent line. This side is a tangent line. You don't have to worry about that too much. Just be okay with the fact that this right here is perpendicular, this right here is perpendicular, and this right here is perpendicular. As long as you're okay with that, we can go ahead and just continue with this. So if we have our three sides, let's call them A, B, and C. We can split this up into three different triangles. So I'm going to have a purple triangle down here. So this is my purple triangle. I'm going to have an orange triangle to the right. So this right here is my orange triangle. And then I'm going to have a blue triangle on the left. Look good so far?
Yeah.
Okay, so each of these triangles, the blue triangle is equal to A times R over 2, right?
R as in the radius?
Yes, the radius of the circle on the inside. It needs to be the same no matter where that radius is drawn. My purple triangle is going to be C times R over 2. Does that look good to you?
Yeah.
And then my orange triangle is going to be plus B times R over 2. So now I add these three together because I want the area of my total triangle, right? So that's just going to be all three of these added together. That's A plus B plus C times R divided by 2. And the reason why I'm able to do that is because they're all being multiplied by the same thing. This is the distributive property. Look good?
Yes.
Now I can separate this out to become A plus B plus C divided by 2 times R. And this right here is just half of my perimeter.
Uh-huh.
And that's the formula that we were using.
Oh.
This right here is just equal to the area of my triangle.
Okay. Okay, got it.
Yeah. So the area of your triangle is equal to half of your perimeter times the radius of the inscribed circle. Right. Let's go ahead and move on to the next question then, if there's no other questions here. Right. Problem number 3. A standard deck of playing cards has 52 cards divided into 4 suits: clubs, diamonds, hearts, spades, in that order. Each suit consists of 9 number cards, each containing a different number from 2 to 10, and 4 face cards that include a jack, queen, king, and an ace. In the game of cribbage, points are earned if you can combine 2 cards that sum to 15. Jacks, kings, and queens each have a value of 10. Aces each have a value of 1. And all number cards have a value of the number shown. How many different unordered pairs of 2 cards sum to 15 in a standard 52 card deck? So a couple things. We do mention that they have to be unordered. In other words, like a 5 of spades and a 10 of hearts in that order is the exact same as 10 of hearts first, then a 5 of spades. However, if I change the 5 or change a 10 suit, that is a completely different pair. So any ideas here from anyone? Did anyone get to do this question here? Anyone?
No.
No one? Okay.
Nope.
Let's see. Gracie, have I had? Do you help me out yet?
No.
right.
What does it mean by unordered pair?
Yeah, so what I said is like if you have a 5 of spades, let's not use spades. I'm not good at drawing spades. If you have a 5 of diamonds and a 10 of hearts, let's say, right? That's the exact same thing as having 10 of hearts first and then a 5 of diamonds. Make sense?
Yeah.
So it doesn't matter which card is first, it doesn't matter which card is second, but it does matter which card you have. In other words, if you have a 10 of hearts versus a 10 of diamonds, those are completely different pairs. Okay, let's go ahead and take a look here then. All right.
For the cards 1 to 15, I think you have 8 ordered pairs for that.
So what do you mean by 1 to 15? You don't have.
Really?
Your numbers only go up to 10.
2 to 15? Oh, then what numbers are the number cards? 2 to 10?
Yeah. So the number cards go from 2 to 10, but your face cards are also each worth 10 points. Remember, jacks, queens, kings have a value of 10. Aces have a value of 1, right? And you're looking for 2 cards to sum to 15.
I'm not so sure.
You're not so sure? Okay. Let me ask you a first thing then. So since we're told that the order doesn't matter between the 2 cards, can I just say that the smallest one is always first?
Yeah.
Yeah, because if I list the smallest one always first, then because the order doesn't matter, that takes care of that pairing, right? So if I take out 2 cards, I just always say the smallest one first because that will take care of the pair. Okay, so if my smallest card needs to be first, can my smallest card of my 2 cards be a 1?
Yeah.
It can. It can be an ace. I can get a total of 15 with an ace and another number and another card.
Oh no.
Why not?
There aren't any cards that equal 14.
Yeah, there's no other cards that go up to 14, right? So you cannot use that one. So what about so what's the smallest card that you can use then?
That would probably be 5.
5, right? And if you use a 5, then what other card does it have to be?
A 10?
A 10? Do you only have one choice there?
Jack, queens, and kings.
So your first card needs to be a 5. So a 5. So let's make this a little bit bigger. A 5, right? Your second card needs to be 10, jack, queen, king. Does that look good to you?
Yeah.
So how many ways are there for you to get a 5 and then a 10, jack, queen, or king? So how many 5s do you get to pick from?
1.
You only get to pick 1 5 from a 52 card deck?
Isn't it just 5?
Well, yeah, but you have 4 of them, don't you?
Oh, yeah.
So which 4 5s are there for you to pick from? Can you explain it? Like, why do I say there's 4?
I don't know, but there's
You don't know.
10, J, Q, and K.
Well, yes, but that doesn't have to do with this part yet. We're just looking at the 5s. Why are there 4 5s for you to pick from? Gracie, have you ever played with a deck of cards before?
No.
Oh, you haven't? Okay, that's probably why.
Oh, so each one needs to be matched up with the other card.
Not yet. No, that's not the case. That's not the case. Like you've never played poker, anything like that? No?
No.
You should. You really should. It's gonna help you out a lot with this kind of question. So like, yeah, I would definitely tell you like play around with some cards at some point. That'll help you out with this kind of question a lot. You actually see standard like playing card questions a lot on AMC, on stuff like that. These actually come up quite often. So if you've never played with playing cards before, it's actually really hard for you to know. Okay. But let's go ahead and see if someone else knows. I guess Isabella, why do you have 4 different 5s for you to choose from?
Because there's 4 different like cards of that one thing in total?
Can you kind of explain a little bit?
I don't know. Well, I don't know because the decks I play with are like 24 in a deck, but this one says
What?
it's 52.
That's crazy.
Well, I don't
Okay.
know. I just think most of the ones that I get are just 24. They're like the thin ones.
I've never seen those before. Wow. Okay.
Do you want me to share my screen and show you one?
Nah, we're fine. No, that's wild. I've never seen that before. Anyways, okay. So what we're seeing here is that let me just go ahead and explain it then. So we're told that your playing cards are divided into 4 suits, right? Clubs, diamonds, hearts, and spades. So there's 4 different suits. What this means is that each of your suits has an ace. Each of your suits has a 2. Each of your suits has a 3. Each one has 1 through 10, Jack, Queen, King, right? So what that means is that there's 4 copies of each card in the deck. There's a 5 of clubs, 5 of diamonds, 5 of hearts, and a 5 of spades. So Gracie, does it make sense why there's 4 different 5s for you to choose from?
What?
There's 4 different suits that the 5 could have. Does that make sense?
What are the suit? Oh,
Let me playing card deck, I guess. So you can see here, right, that each of your, yeah, I think this is actually just the easiest way to see this. But you can see, right, like each of your cards, there's clubs up here, right? Hearts, spades, and then diamonds. But you can see how there's 4 different 5s here, right?
yep.
So that's why there's 4 different choices for you here, because there's 4 different 5s that you could pick from, right? You could have picked any of the 4 suits. You could have picked clubs, diamonds, hearts, or spades. So that means that you have 4 choices for the number of 5s that you have. And then how many choices do you have for 10, Jack, Queen, King then?
4.
You have first 4 choices, right? You have 16 total choices because you first get to pick, hey, is it a Jack, Queen, King, or Queen or King? And then second, what suit is it? So there's 16 total choices here. So this gives you a total of 64 already. Okay, next up, what about if your lowest card is not a 5? What if your lowest card is a 6? What does your other card need to be?
It would be 9.
9, right? 6 and 9 add up to 15. So how many choices do you have here for how many ways this could happen?
It would it be another 64? No, not 64. Would it be 16?
Yeah, it would be another 16, right? Because you have 4 choices for the number for which 6 you use, and then 4 choices for which 9 you use. Right, for a total of 16. And then next, you could have a 7 and an 8, right? How many ways are there for this to happen?
There are 16.
Can we keep going? 8 and 7, are we able to do that?
No, because
Why
it
not?
says unordered.
Right. Unordered pairs, we've already taken care of this with our 7-8 pair. So that means that our answer here is just all of these added together, which is a total of 96 different options. Did that make sense, Gracie?
Yeah.
Yeah, so for this question, it's really helpful if you know what a deck looks like. But yeah, that's gonna be really, really important. Now, but yeah, I promise you, this is like as soon as you see it kind of like 1 or 2 times, it makes a lot more sense, right? Like each card, there's 4 different suits. Each suit, there's 13 different cards. But yeah, that's really about it here. We can go ahead and move on into the next question if there's no problems here. Any questions on problem number 3 there? I can just undo if you guys had any questions, and then I'll bring back that all the notes that we had. No questions? All right, let's go ahead and take a look at.
Can I take a screenshot of that?
Yeah, so the idea was we cannot do this. Oh, we cannot do 8 and 7. It's already been counted.
Oh. Okay, thank you.
Yeah, no problem. All right. All right, let's go ahead and move on then. So problem number 4 here. The sequence 1, 3, 6, 10, 15 is called the triangular numbers. And the nth element of the sequence is found by adding the first n positive integers. What is the positive integer that, when multiplied by any triangular number, always yields a product 1 less than a perfect square? Okay, let's take a look here. Any ideas here? Did anyone get to do this one?
No.
No?
I just did trial and error.
Okay, what answer did you get?
I got 8.
So 8 does end up being the right answer, but trial and error is not the method that we want to be using. Now this method is a little bit challenging, so I'll go ahead and explain it a little bit. But yeah, so 8 is the correct answer, and you can kind of see that by, okay, does 1 work? No. Does 2 work? No. Does 3 work? Like you can just kind of test on the first few numbers. Okay, so first off, the triangular numbers is just 1 plus 2 plus 3 plus 4 all the way up to plus n. And we all know that this right here, I've mentioned it a couple times in this class already, but this is just n times n plus 1 divided by 2, right? N times n plus 1 divided by 2. All right. Well, this is n squared plus n divided by 2, right? So what we're saying is we want this times some other number, let's call it m, to equal something squared. Always, always, always equal something squared. Well, this right here, n squared plus n, this is very close to something being squared, right? This right here, right, we said that we're looking for a number that is always 1 less than a perfect square. This right here is very close to something being squared. N squared plus n plus 1 over 4 is equal to n plus 1/2 squared. And the reason why I know this is because this is actually a process that you're going to learn later on in algebra or algebra, either algebra or algebra 2, but this is called completing the square. We don't have enough time to talk about it right now. We don't have enough time to talk about it today. If you're interested, just go ahead and look up this. But the idea is that if you have something of the sort of a plus b squared, you should know that this is equal to a squared plus 2ab plus b squared. Well, we already know that this a needs to be n, and we already know that 2ab needs to equal n, right? We already know that n equals a, so we know that 2ab equals n. That means that b must equal 1/2. So that means that the last thing we're missing over here, that's just b squared. So that means we're missing this 1 over 4. So in order to get that 1 over 4, we need to add it and subtract it, because that's the same thing as adding 0. So then this right here is the same thing as this plus 1 over 4 minus 1 over 4. And now we can simplify this out to equal that. So this right here, n times n plus 1 over 2, that's the same thing as n plus 1 over 2 squared minus 1 over 4 divided by 2. And you'll notice that if I multiply all of this by 8, that's the same thing as multiplying this by 4, which is the same thing as multiplying n plus 1 over 2 times n plus 1 over 2 times 4 minus 1 over 4 times 4, which is 1. Now, is this an integer squared? If I split this into 2 different multiplying by 2's, this becomes 2n plus 1 times 2n plus 1, which is indeed always an integer squared. So that is why 8 is your answer. For this question, you did need to understand a lot of algebra. You did need to understand this a plus b squared formula very well. And you also needed to understand the completing a square method. And that's what you need to do in order to answer this question. So for this question, if you guys aren't familiar with this topic, go ahead and take a look at this. There's definitely some sources that you can take a look at, either in like Khan Academy, or there's a lot of different places that'll definitely have something over this. But yeah, so this is completing a square, and this idea up here is very standard for that. Are there any questions? But yeah, definitely trial and error would also get you your answer here. All right. So that's going to be it here for today. Next time, we'll try to wrap up the team round questions by doing problems 5 through, I believe, 10. If we are able to finish, then we'll call it a week, and that's actually going to be it for the semester because we only have one more class here. But with that, that's going to be it here for today. I'll see you guys next week. All right.
Bye.
Bye.
Yep. See ya.